I can't sleep, so I think I'm going to try to mathematically prove the product rule. By the way, if you're watching this on the 4th of July, happy Independence Day. So the product rule can be defined as follows. That is, the derivative of some function times another function equals the derivative of the first function times the second function plus the first function times the derivative of the second function. In this case, we're using u of x and v of x. So the derivative of u of x times v of x equals u prime of x times v of x plus u of x times v prime of x. This is the product rule. This is what I'm going to attempt to prove. And just one thing to note, d over dx, well, this is the derivative, but this is the same thing as saying dy over dx. So that is the change of y with respect to the change of x. All right, so let's play. I will begin with the assertion that the change of y with respect to the change in x is the same thing as the limit as the change of x approaches 0 of the change in y over the change in x. We just want to have the understanding that the change of y is the amount that y changes when you move x to x plus the change in x. We want to prove the product rule. Another way to write the product rule is as follows. So that just says that the derivative of u times v is the same thing as v times the change in u with respect to the change in x plus u times the derivative of the change of v with respect to the change of x, which is essentially the same thing as v times u prime plus u times v prime. I guess I don't need to put a dot there. And that's what we wrote before. This is just saying the derivative of v. This is just saying the derivative of u. Or imagine we take x and we change it to x plus the change in x. Well then, that would mean that u changes to u plus the change in u. And of course, well, v would change to v plus the change in v. This means that, well, u times v, and that's going to change to u plus the change in u times v plus the change in v. But how much of a change is this? Well, we can take the difference between the old and the new quantities. And if we do this, we'll find that, and I'm just going to do this over here. Well, the change in u times v, well, that equals u plus the change in u times v plus the change in v minus u times v. So if we expand this out and then we cancel, we're going to end up with the change of u times v, right? But that's going to equate out to be v times the change in u plus v times the change in u plus u times the change in v plus the change in u times the change in v. So now it's like, imagine that we take this equation and we divide the entire thing by the change in x. In the case of the last term, we'll divide it with an extra change in x, but then multiply it by it once more to make things balance out. So we're going to end up with the following. That is the change in u times v over the change in x. That's going to equal v times the change in u over the change in x plus u times the change in v over the change in x, because everything is getting divided by the change in x, plus the change in u over the change in x times the change of v over the change of x. And then at the tail end of this here, we're going to multiply it by the change in x. So now, well, if you take the limits as the change in x approaches 0, well, then all of the ratios are going to go to the corresponding derivatives, but then the final factor of the change in x goes to 0. So it should be something of the sort, um, well, the derivative of um, the derivative of u times v equals v times the derivative of u plus u times the derivative of v plus the derivative of u times the derivative of v times 0. But if you look at this here, you'll notice that this last term here, well, this is multiplication by 0, which means that this whole thing, well, this is just going to go to 0. And then if you look at what we have left over, that is the derivative of u times v equals v times the derivative of u. So we could just put this as u prime, the derivative of u, plus u times the derivative of v. And we're just going to put v prime. And hey, what do you know? This is the product rule. So we have just proved the product rule. Thanks for watching.